Osmoregulation, the maintenance of constant osmotic pressure in the fluids of an organism by the control of water and salt concentrations. Osmoregulators control water uptake and loss in a hyperosmotic or hyperosmotic environment. I can't help but going to the bathroom 2 to 3 times per night, and I don't know why.
You probably drink too much water before bed.
What you're experiencing is nocturia. Nocturia is the feeling to pass urine at night.
What causes nocturia?
A recent study from Nagasaki University explains how a person can reduce nocturia. The researchers took 300 people and hypothesized that the amount of salt intake in their diet will affect how much a person will have to go to the bathroom at night. The researchers took 300 participants and made two groups. One group increased their salt intake in their diets while the other group decreased their amount of salt intake. Each participant wrote down how many times they went to the bathroom at night and compared their results. For the group that decreased their salt intake, their trips to the bathroom decreased significantly to over 2 a night to around 1. As for the group that added more salt to their diets, their trips to the bathroom a night increased. These results actually change what doctors focus on when they treat their patients who have nocturia. Now, doctors can help improve the quality of life in their patients by correctly giving them the knowledge to decrease salt in their diets.
The excretory system is composed of 4 different phases: the filtration phase, the reabsorption phase, the secretion phase, and the excretion phase. Filtration happens when blood enters the kidney through the renal artery. It's jam-packed with nutrients, water, protein, and other elements the body needs. It also has waste the body wants to dump. When blood flows into glomerulus, blood pressure forces the water and solutes out of the capillaries and into the lumen of the Bowman's capsule. The lucky water, salts, amino acids, vitamins, and waste that make it into the capsule are collectively called the filtrate. With reabsorption, the filtrate travels through another series of tubules, the proximal tubule, and then the loop of Henle. As the filtrate moves through this part of the nephron, the body fluids reabsorb lots of essential nutrients. The filtrate takes a steep turn down towards the medulla and into the descending loop of Henle. The body does some more reabsorbing on this leg of the trip, but the only thing the body is sucking up is water. The tubular membrane in this part of the nephron is selectively permeable to water, so it prevents salts from being reabsorbed, upping the filtrate concentration and osmolarity in the loop even more.
In the next phase of urine's journey, ions of water can be secreted into the tubule. It's the opposite of reabsorption. Instead of the body pulling all the useful stuff it can from the tubule, now it pumps the extra stuff back in. The filtrate gets to the top of the loop, it levels off and enters the distal tubule. After the distal tubule, the urine flows into the collecting duct, which is the body's last chance to squeeze out any bits of watery goodness before saying sayonara. It's here that the concentration of urine is determined and regulated. Between the two of them, osmoregulation and excretion make sure that our bodies retain water when we are dehydrated, and that we produce dilute urine when we have been gulping down copious amounts of water. Your body removes unwanted fluid by filtering your blood through your kidneys. Here, any fluid is sucked out of the bloodstream and put into your bladder to be removed as urine.
To do this, your kidneys use osmosis to draw the extra water out of your blood. This process uses a delicate balance of sodium and potassium to pull the water across a wall of cells from the bloodstream into a collecting channel that leads to the bladder, reducing the ability of your kidneys to remove the water. The result is a higher blood pressure due to the extra fluid and extra strain on the delicate blood vessels leading to the kidneys.
Over time, this extra strain can damage the kidneys, which leads to kidney disease. This reduces their ability to filter out unwanted and toxic waste products in the bloodstream, causing unwanted substances to start to build up in the body. If kidney disease is left untreated and the blood pressure isn't lowered, the damage can lead to kidney failure. This is when the kidneys are no longer able to filter the blood and the body slowly becomes poisoned by its own toxic waste products. If you have high blood pressure and are being treated with a diuretic medication, this makes the kidneys remove more fluid from the bloodstream. Because the sodium and salt counteracts this effect, reducing your salt intake will make your blood pressure medicine more effective.
The supply forms are going to be...
I have to go to the bathroom. I have to go to the bathroom.